In section 9.4, we're going to be looking at symmetry. We'll look at a few different ideas. First of all, identifying lines of symmetry, identifying rotational symmetry and the angle of rotation, and then also identifying symmetry within a 3D object. So we have three different types of symmetry that we're going to be talking about. We first of all have line symmetry, which is also known as reflectional symmetry. And this is the typical symmetry that you may think of when you hear something being symmetric. It's when you have a line that you could fold your object over on and it'll fall right back on itself. So for instance, this is a line of symmetry for a trapezoid. It cuts this trapezoid down the middle, so if you were to fold this half over, it would end up exactly on the other side. We also have rotational symmetry. This is a little bit different. This is taking something, and if we spin it, it can fall back on itself again. So this triangle, for instance, if I take it and I spin it a little bit, this vertex here will come to this one would go to that one, and that one would go to that one. I can spin that triangle, and I can get it to appear exactly as it was before. Now, we have what's called an angle of rotation for rotational symmetry. And in this case, it's 120. The way we figure that out is we find the center here, and we're going to draw these dotted lines. Let me use a color that stands out a little bit more. We're going to draw these dotted lines in, and I see that now I have this central angle that I can look at. So I have 360 degrees divided by 3, because that's how many different angles I have making this up, which is also the number of sides of this polygon, and that gives me 120. So I know every 120 degrees, that shape is going to fall back on itself again. Now, our last type of symmetry is called point symmetry, and this happens only when you have rotational symmetry of 180 degrees. So if you happen to have symmetry of exactly 180 degrees, then we just call that point symmetry. So this polygon, if I take it and I just flip it 180 degrees, it'll fall back on itself again. All right, so let's look at this first example. We're going to identify how many lines of symmetry a regular hexagon has. So I'm going to go ahead and grab my marker. Okay, so I've got a hexagon drawn here. If I look at this hexagon, I could fold it in half going through these vertices. I could fold it in half going through these vertices. I could also fold it in half going through these vertices. So I just want to look at our vertices to see if we can fold that shape in half going through there. So far I have 3 lines. But I can also take this shape and I can fold it in half going through my sides. Fold it through this side and also through this side. So now I see that I have 6 lines of symmetry. 3 of them came from going through the angles. Those are my white lines that I have drawn on here. And the other 3 came from splitting my sides. Those are my yellow lines. So what I want you to do in this first you try is go ahead through, and I want you to draw a rectangle that is not a square. So make sure it really looks like a rectangle, not a square. And then determine how many lines of symmetry you can create. Here we're going to look at rotational symmetry. So the directions say decide if each figure has rotational symmetry. If so, estimate the angle of rotation. So I have to look at my angle of rotation. And I kind of explained this to you a couple slides ago. But what we're going to do is we are going to draw lines connecting to the center of our shape. Let's try that. Okay, so I'm going to draw this line here, that line there. I'm going to draw here, here, here. So I'm connecting all of the vertices of my shape, all of the corners, I'm connecting to the middle. Now here, I'm going to take 360, and I'm going to divide it by 3. I get 120. Which is similar to that original picture we had of this triangle, right? But in the original image, we had an equilateral triangle. Is this triangle equilateral? That's what we have to ask ourselves. And it doesn't look like it to me. So I do not think I'm going to be able to spin this 120 degrees. I don't think that's going to work. So this picture just does not have rotational symmetry. I can't spin it so it'll end up back on itself again. The star, though, if I think about the star, I can spin it and have it end up back on itself again. And I can spin it by 360 divided by 5. That gets me 72 degrees. So I do have rotational symmetry here. Every 72 degrees, we're going to end up in the same exact spot. So 72-degree rotational symmetry. The reason A does not is because it's not equilateral. B is a regular polygon. It's a star. It will fall back on itself. So then you have a second U-try problem here. You're given this image, and you are asked if it has rotational symmetry. And if it does, they want you to estimate what that symmetry is going to be. So take a look at that picture. Now we also have symmetry within 3D objects. And this is a little bit harder to see simply because it's not flat on paper. You have to really think about it. But within 3D objects, you have reflectional symmetry and you have rotational symmetry. Reflectional is when you can slice it into congruent halves. So if you can slice an object into two congruent halves, then you have reflectional symmetry. So it's like taking a tissue box and slicing it through the middle. You also have rotational symmetry, which is when you can rotate something about a line. So an object can be rotated about a line so that the image matches the pre-image. So this is like if you took like a Pringles can. It's like a Pringles can of potato chips and you put a pencil going up through the middle of it. You could spin that Pringles can, and no matter how you're spinning it, it's always going to look the same. It's going to be a congruent image. Another example would be like a tennis ball container. If you put a pencil through the tennis ball container, you can spin it, and it'll end up looking congruent. In either of those cases, though, our pencil had to go up through the middle of the container. If we kind of like put the pencil through the side of the container, now it's going to look different. So let's look at a couple of examples here. I want to see in this figure A here, do I have reflectional symmetry? Reflectional symmetry. And then also, do I have rotational? It is possible to have both, so we're going to have to consider this. Do I have reflectional? So can I cut this thing in half in any way so that I will have congruent pieces? And I can. It's really hard to show it on here. We're going to look at this more in class so we can see. But I could take this and I could slice this bowl through the middle with this plane. If I slice it like that, and I would have two congruent halves. Right? Like I take this bowl and I just kind of split it in half. So I have one half in each of my sides. So that would be reflectional symmetry. In terms of rotational symmetry, I could take my pencil and I could stick my pencil up through the very bottom of the bowl, and then I could spin my bowl around that pencil, and it would always be looking the same. So I believe this has both reflectional and rotational symmetry. Now this picture is a little bit more complex, right? And you can see that it's got this higher lip here, it's got this handle. So if I slice this thing, the only way I can slice it to have it be exactly congruent is going like through, let me try with another marker here, through this way. If I slice it right down the middle there, so that half the handle is on one side and half the handle is on the other, and half of this spout is on one side and half of it's on the other. So I do have reflectional. In terms of rotational, there's no way that I can put a pencil through this thing and spin it and have it be the same. Like if I put a pencil up through the middle, like right here, I can't spin it and have it look the same as it did before until it gets all the way around to where that handle is back to where it was again. And because that has to go all the way around, that can't be considered rotational symmetry. Rotational symmetry has to be less than 180 degrees. So if I have to really spin it all the way around 360, sure, you ended up the same place, but that's not symmetry because it's nothing special. You just spun it all the way around in a circle. So it's symmetry when you have an angle of rotation which is less than 180 degrees. If it were equal to 180 degrees, remember, it's called point symmetry. Okay, so then there's a U-try for you. You're looking at this lamp, and you're trying to figure out if it has reflectional symmetry. So can you slice it into two congruent pieces? And also, does it have rotational? So can you like stick a pencil through it somewhere and spin it around that pencil and have it look the same?